Hi and welcome to this video. In this one, we're going to talk about data types in TypeScript. So hit that subscribe button and let's get started. TypeScript is a superset of JavaScript. We talked about JavaScript in a previous video. JavaScript is being used primarily for web development where we create dynamic and interactive content. Now, TypeScript is a superset of JavaScript. The only difference between TypeScript and JavaScript is that TypeScript has types. JavaScript was a dynamically typed language. That's why we could change one variable's type from one thing to something else, like from string to a number. But TypeScript is statically typed. So you need to specifically say what each variable's type is going to be, or TypeScript is going to decide that for you. So technically, any valid JavaScript file is also a valid TypeScript file, except for when the JavaScript concepts or code clashes with the way TypeScript handles code. So I'm going to copy this, paste it right here, our previous file, and this one, I'm just going to say, let's change the extension from .js to .ts. Let's get rid of the copy. And then you can see the icon also change. I'm going to say B. Now, as soon as I do that, there is a bunch of errors. The reason for that is, as I said, when it is in clash with the TypeScript philosophy, then it is going to throw an error. Why there is an error? First, let me comment out these. First, I need to explain to you how TypeScript works. Then you're going to understand why there are errors. So you can see, let something in JS, we can just change this, all of this, to TS. You can see that works. We had the same line in JavaScript and we have the same line in TypeScript, because TypeScript essentially is JavaScript, but better. That's why we use it more and more and more with our front-end frameworks. So we can see we have the same string. Now, if I were to hover on this variable, something interesting happens. We have our initializer, we have our pointer right here, and then what do we have here? Here it says string. And then you can see we have that colon, the same thing that we had inside our objects. So that colon is basically signifies the type of our variable. So this is a string, which means John Doe is a string. Now, TypeScript is statically typed. That means once you declare the type, you're not allowed to change that type. So that's why when I comment this one in, it is going to throw an error. Why do we want this error to be thrown? Why didn't it throw it in JavaScript? Because JavaScript is very loose. That's why we use TypeScript. TypeScript is supposed to be better than JavaScript, and it is. The reason for this is when we say, okay, something is a string, most of the times we don't want that to be a number. It's a string. If we want it to be a number, when we create applications, we create some other variable or pointer, and then we put a number in there. We don't change the type. And the idea or the benefit of this is so it doesn't throw errors when we go to production. It throws error during the development phase. That's why TypeScript doesn't exist in production. TypeScript is actually a development thing, aka a development dependency. And what does that mean actually? We run JavaScript in the browser. We cannot run TypeScript in the browser. We need to convert TypeScript to JavaScript, then run that JavaScript in the browser, right? So that's why. But why? Because this helps us, this a little bit more setup. It helps us catch a lot of bugs. It helps us catch that undefined inside the console before actually going in there. Before going to the console, running the code, you're going to catch that this is not allowed. So if I hover on this error, it says type number is not assignable to type string. Keep in mind, when you have these kind of errors, they're called type errors. They are called type errors. And always they're going to say something on the right hand side is not equal to or is not the same type on something on the left hand side. So they start from the right hand side and then they go to the left hand side. So that's why if I hover on this, it says type number. Where is type number? Now it doesn't say the value. Keep that in mind. This is type. It's not the value. It's the type of the value. Even though this is 12, what is the type? The type is number. Number is not the same as string. It's not assignable to type string. So now you could either say, you could convert it to a string like that, or you could say 12. And then it's okay. But then if this was const, that would still throw an error. Now this is what I mean. You can see we didn't go to the console and we saw the error immediately. What does it say? Cannot assign to this because it is a constant. Now in the previous video, we went to the console, we ran it, we got a big error and we got scared and we say, okay, what is that? And then it was basically the constant reinitialization. We don't want to do that. But TypeScript gives us that immediately. Now that you know what this is, let me go back to there. Now that you know that, we need to initialize each variable individually. But then the name should not be the same. So let me comment that one out. If I hover on this, we have the type number. So we have all the primitive data types of JavaScript. In TypeScript, the only difference is that they have static types. We have all the non-primitive data types of JavaScript in TypeScript. Again, the difference is that they're statically typed. So we have a type string, then we have a type number. For this one, if I were to comment this one in, it's throwing an error. We need to initialize it with let. This is going to be of type Boolean. You need to keep in mind these types. We're going to use them. And then we have a type undefined. If I hover on it, you can see it's a type of undefined. We have a type of null. And no, null is not the same as undefined. And even TypeScript says that. You can see this variable is undefined. We change its value to null and it says type null is not assignable to type undefined because null and undefined are different things, but the concept is the same. There is no value. When it comes to the actual value, both of them are the same. Both of them signify the lack of a value. But in type, they're different. In pointers, they're different. All right. For this one, let me comment this one and let's save that. We get this big int type. Now, for TypeScript, you don't have to do this type of operator to know the type. You're immediately going to know that if you hover on it. And now you can see for none of these, I have defined a type specifically. This is called type inference. So TypeScript is inferring the type for you. So you get to programming. You don't say, okay, now I'm not going to use TypeScript because I'm going to have to type annotate everything. It takes too much time. No, it doesn't. Because most of these things, you don't have to type annotate them. I mean, you could say, okay, since this is a string, I'm going to say it should be a type of string. This is called type annotation explicitly. You explicitly do that. But when TypeScript does it for you, that's an implicit type annotation. That's called type inference. You could do it like this, or you could go and let TypeScript do it for you. Both are correct, but if you let TypeScript do it for you, it's faster. There are some situations where you would want to type annotate something because you want to show to yourself, okay, this is the type. I should not make any mistakes. You want to show your code to some other developer, and immediately when they take a look at your object, they know, okay, there is all of this and all of these are the types. I go over all of that in my other playlist. If you're interested in front-end web development, that is React from Confusion to Clarity. You're going to see TypeScript in action there. But here we just want to talk about the problem-solving aspect of a programming language, which is called TypeScript, much like as JavaScript. So that part is also done. Let's take a look at how TypeScript type annotates an object. Now for these objects, especially if your object is longer in members, it would be a good idea to type annotate it. So if I hover on this, you can see we get the object syntax. We have all the members along with their type. So it says name is a type of string, breed is a type of string, age is a type of string. Now keep in mind, this string is not literally the type of name word itself. It says this name value, this name key, it should receive a value that has a type of string. I don't care what this actual NAME word is, whatever this is. The value that it receives, it should be of type string. For the breed, the value should be of type string. For the age, the value should be of type string. Now, later on in this video, I believe we're going to talk about index signatures, where you can define the type of the key and then you can define the type of the value. You could do that in TypeScript as well, but everything in good time. So this is how it type annotates an object. We could take a look at how it types annotate in an array. Now keep in mind, whenever it type annotates an array or an object, you need to take a look at their syntax. So for an array, we have these square brackets. For an object, we have these curly braces or curly brackets. So in type annotation of the object, we saw the curly brackets, but in the type annotation of the array, we're going to see the square ones, because that signifies the syntax of an array, or the grammatical aspect of an array. And then what does this array contain? It contains numbers. That's why it says it's a type of number. It's very interesting when it comes to how TypeScript type annotates an array that contains numbers and an array that contains a bunch of strings. So you can see now it's more specific. It says type string. But then if I were to add number in here as well, 1, 2, and 3, I'm going to say mixed. Let's say mixed. Now this is going to be number and string. So this is called a union type. This pipe character, this is a union type. The union type is used to signify, you might remember math like from high school or whenever, where you had like sets, set, the intersection of sets, the union of sets. It's the same idea in TypeScript. So we have this union. This means that this array could have either strings and or numbers. That's it. That's what it means. It could have string or number, or it could have both. And then what is the data type? It's an array. That's why there is the array syntax. This is a union of two different types. And then if you were to add a true here, what do you think is going to happen? A union of three types, because now what you have is Boolean as well in there. Now it's an intersection of three types. So this is how TypeScript type annotates, and you can take hints from these type annotations as well. Let me just comment these codes out. So the first two parts are done. The way we declare a variable, let var const, it's the same in JavaScript and TypeScript, so I'm not going to talk about that. We also talked about non-primitive types, but when it comes to non-primitive types, you have another type as well. That is called a tuple. Yes, you heard that correctly. Let me get rid of this variable declaration from here. We don't talk about that here. It is called tuple. You're going to hear people call it tuple, tuple. I like calling it tuple, like T-O-O-P-L-E, tuple. So this is basically another data type in TypeScript that we don't have in JavaScript. And the idea behind this is it gives us a fixed length array with known types at each index. Basically what this helps us to do is to represent data structures where the position and type of each element is strictly defined. For example, you have coordinates like X and this, and then Y and this, or you want to return multiple values from a function. Now, as far as a tuple is concerned, it doesn't matter how many items are in there, as long as it is a fixed size. So let's say let user info. I am going to type annotate this later, not now. I'm going to say, okay, this is the first user. The name is Alice, and maybe like they are online, and I'm going to say I'm true. So if I hover on this, what am I going to see? I'm going to see whatever I saw right here. So it's going to be a string, a number, and a true. It's going to be a normal array type annotation. But this is not what I want. I want it to be strictly this structure. So I need to type annotate it. I'm going to say, okay, the first values type is number. The second one is string. And the third one is Boolean. Whoops, why did I put string inside strings? And there we go. So now if I hover on it, you can see this has a fixed size, 3, and then it has its types predefined. What is the difference? You might be asking, okay, why are you doing this? What is the difference between this and this, what we saw? Okay, we saw string, number, Boolean, and then, okay, we said there is an array of that. I'm going to say user info 1, user info 2. I'm going to say Sandra, and then let's set it to false. They're not online. Maybe Alice is number 2, whatever. So you can see even the order doesn't matter. So if I grab the string, put it here, wouldn't make a difference. The first one, let's grab the number, put it after the Boolean, and now let's get rid of that. You can see the order is different, but now if I hover on it, this is an array, but this is a tuple. What is the difference? The difference is that I can add another number here. I can say 23. I can say hi, another string. I can add all of those in there. So it doesn't matter how many items I add, it's always going to work. But when it comes to this tuple, as soon as I try to add hi, there is going to be an error. Why? Because it says, keep in mind, always from right to left. What do we have? We have type number, string, Boolean, string. So number, string, Boolean, string. Number, string, Boolean, string. And it says is not assignable to type number, string, Boolean. Number, string, Boolean. Source has 4 elements, but target allows only 3. See? It's a fixed size. Why? Because I want my user info to be always like this, so I don't make a mistake. So sometimes I'm tired, I add something else. Or in a real work context, you're working in a team. Someone else adds there something. Now, as soon as you add a tuple, the other developer will know that they're not supposed to add anything inside this array because it has a type of a tuple. But if you see this, you're allowed to add something else. So this is the difference between a tuple and an array. And yes, all of these are called type errors in TypeScript. They're called type errors. Let me comment out. I'm going to keep it there for your reference. Now, after this, with this, our object types are also done. So we talked about primitive types, all of them. We talked about object types, where we had an object, an array, and a tuple. Next up, we're going to talk about something called special types. In here, we're going to talk about any, unknown, void, as well as never. So special types are special. They serve specialized purposes in TypeScript, often controlling how strict or flexible the type checker is when we define certain variables. Now, to be able to show you the any type, the first one is going to be the any type. As the name suggests, the type is any. It could be anything. Now, with any, what you do is you lose that type safety feature of TypeScript. You lose that. And your variables are going to act as though they are inside a JavaScript file. So if I were to, instead of string, I would say any, and if I say that, aside from this variable declaration, there is no problem, because I said the type could be anything. Here it says the type is any, and here it is again any. So by definition, I should be able to use it like that. See, now it is a normal JavaScript file. The type is any. Why is this useful? Sometimes you don't know what the type is. You get something from a library, you get something from a fetch request. You don't know what the type is. Initially, you're going to say any, and then you're going to change it. You want to basically your app to start working. All right. So this is one special type. The other one is unknown. You could say that any is really unsafe when we talk about type annotation in TypeScript, because the type could be anything. And as I said, maybe you're making a fetch request, and until you get the data, you want to put something in the app to just satisfy TypeScript, because TypeScript is going to say, okay, it has a type of any. Now, when you're working with TypeScript, oftentimes, most of the times, or I should say always, there's going to be a TypeScript configuration in which you're going to add a setting to prevent you from using any. All right? So if the type is any, it's unsafe. There is a safer alternative, still not so safe, but a safer alternative. It is called unknown. And the way you would add it, you would just say unknown. I don't know what the type is. I'm not saying that the type could be anything. I'm saying I don't know what the type is. I am going to pass an unknown, and whenever I see unknown in my code, or I see unknown in someone else's code, I know that they don't know what the type is, so they passed in unknown. So it's better for us to find out what the type is. So that is type unknown. But the behavior is the same. Keep in mind, see, the behavior, we don't get an error because unknown and any, they behave in the same way. You don't know the type, so the type could be anything. But this just gives a better code readability for code maintenance. When you see unknown, you know what you don't know the type, so the type could be unknown. Then there is another type which is called never. Never is basically a type that you never reach. For example, you create a function. Let's create it down below here. Let's say we create a function, failed attempt. The attempt has failed. The message, let's say you had a message here that was a type of string, and you say never. Right? And throw new error. Let's send the message. Let's say message. Now, this never type is basically going to say that this function is never going to run. All right? So this basically represents a value that never occurs. A function that throws an error or runs forever. So what you need to do is this type is not something that you're going to type annotate yourself. Sometimes you create some kind of a context, you create some kind of a code that throws a never basically type annotation error that says, okay, you're never going to reach that. For example, if you create a switch statement where you want to check to handle all of the cases, TypeScript will complain if a never returning code path is reachable. So if it is never, it never ends or it never reaches, that is going to be a never type, and it is going to throw an error. So that's never. And then finally, for our special types, we have something called void. Void is very useful. You use it a lot. So for this one, I'm just going to say addition. Now, when I'm talking about addition, let's say A and B. And in here, I'm going to say log A plus B. Simple, right? And in here, I'm going to say addition. Now I'm calling the function. The function requires two arguments. Keep in mind, when you call the function right here, whatever you pass into the function call, they're called arguments. But when you define the function, whatever you pass in here inside the function definition, next to the name, these are called function parameters. So this is the difference between these two. All function parameters must have values, aka arguments. So let's say 10 and 20. So A is 10, B is 20. Now, you can see there is a ton of issues here. So if I hover on this, what is TypeScript saying? TypeScript is saying that A right here, A has a type of any, and B also has a type of any. See? TypeScript type annotated that. Is that what you want? No, we don't want that. So how do we fix the issue? We say, okay, A should be of type number. B also should be of type number. Why? Because you cannot add strings. Well, you could add strings in JavaScript, but you can't do that in Go and Rust, right? So you should say, okay, if there is a string passed, there should be an error. See, it says type string is not assignable type number. What did I say? The right-hand side versus the left-hand side. So this is a string. You cannot pass in a string because it requires a number. You can see how safe our applications are getting as soon as we type annotate them. But then what did the function return? The function returned void. Now, whenever you type annotate something in TypeScript, you can type annotate everything in TypeScript, as well as the return type of a function. So a function has two purposes. It either implements a code and doesn't return anything, or it implements a code and returns something. Our current function implements this code but doesn't return anything because we don't see this return keyword. We don't see that. All right? So when the function doesn't return anything, we type annotate it explicitly as void. And in my opinion, you should type annotate this void. It's a preference. It's my opinion. And the reason for it is because functions are usually going to be, they contain logic of our application. They are sometimes long, sometimes larger functions, sometimes more complicated. But if I want to know what this function returns, as soon as I see void, I know that it doesn't return anything. So even if this function is 100 lines, which shouldn't be, even if it is 10 lines, 20 lines, 30 lines, the logic is complex. I need to sift through the code to be able to know, okay, that the function doesn't return anything or return something. But void immediately tells us, okay, it doesn't return anything. And in my opinion, you should type annotate your functions, all right? And that's it. So this is it for our special types. Now we're going to talk about some utility types that TypeScript has. The first utility type that we are going to talk about is going to be our basically partial type. Let me comment this one out. There is just a ton of stuff that we need to get to. Let me come to the bottom here. I'm going to say comment. Let's talk about utility types. Now, let's create a utility type. The first utility type that I'm going to talk about again is partial. It basically, the way it works is it makes all the properties of a certain type optional. All right. For example, I have an interface. An interface is used to type annotate an object. So you saw the object at the start of this video. You would, if you were to type annotate an object, one way would be to use an interface. Let's say we have an interface user, which means we want to create an object, which is user. The object has a property or a key, which is ID, but the value that this key is going to accept is going to be of type number. The name, which is of type string, and an age, which is going to be of type number. Sorry, number, not string. Let's save that. Now, I'm going to say let partial user, I'm going to type annotate it as this. So I'm going to say partial, and I'm going to open up these brackets, these like angle brackets. They look like HTML elements. They're not, they're angle brackets. And I'm going to pass in a user. Now, as soon as I do this, what is happening? Now, if I were to comment this one out, and if I say let user object obj, it should have a type of user. Now, as soon as I create the object, you can see there is an error because it says this empty object is missing ID, name, and age. So I'm going to add the ID. ID is going to be 1. There is still an error because it is missing name. Now I'm going to add the name. Let's say Jane. It is still throwing an error. Why? TypeScript is telling us, give me the age. See, we have ID and name, but we don't have the age. So let's add the age. Let's say 21. And now everything is okay. But all 3 of these were required. They weren't optional. The way you can make anything optional in JavaScript and TypeScript is you add this question mark. So if you add the question mark, you can delete it from here because now it is optional. And then you add a question mark here and a question mark here, and then you can end up with an empty object. And TypeScript is not going to complain because these are optional. You could provide them or you could not. But isn't adding all these question marks a little bit tedious? This is what this partial type is going to do for us. It's basically going to make all of them optional. So I could initialize it to an empty object, or I could just pass in the name. I'm going to say Bob. It still works because it makes all the members of a certain type optional. Now, we're going to keep this user interface right here. Now, I'm going to copy it. Let's just comment it out. Let's comment this one out. So the first one was, let me put this here. We have the partial. And the syntax would go like this, partial T. T is short for type. That's the common convention, how we go about this. So let me copy that partial, put it right here. The next special one or utility type is required. And yes, it sounds exactly as the name suggests. It's going to do the same thing. So if I have an interface in which I have these members as optional, if I were to go like this, because it's optional, there is nothing, there is not going to be an error. Let's get rid of that. Now, if I were to make this type required, and comment this one in, even though these have question marks, which means they're optional, since we have said, okay, the user has to be required, all the members are now required. And if let me just change this to required. And whoops, required. Save that. If I hover on it, it says type this is missing the following properties: ID, name, and age. And it doesn't matter what I do. Even if I say, okay, oh, didn't I change this to required? Required. And if I say, okay, I did add the name, the other two may be optional. No, you still need to add the ID and the age. So this is the difference between required and optional. And keep in mind, they're very strict. They make all the properties optional or required. Next up, we have read-only. Now, for read-only, you cannot reassign their values. You cannot change their values to something else. For example, we are going to get the same example and we're going to basically keep working on it. This would be read only. And then again, the T is going to be the T. Let's comment this one back in. And for this one, I'm going to get rid of this optional flag. We have our user, and this should be read only. Save that. So if I were to comment this one back in, it does require us to add these members, I mean. So we need to add the ID, the name, and the age. We could get rid of the A, just the ID and the name. So the name, the ID is going to be 1. The name is going to be Bethany. Is that correct? There we go. So now it's read-only. What that means is if I were to grab my read-only user dot, let's say I change the name from Bethany to Sandra, it's not going to work because it says cannot assign to name because it's a read-only property. See? So why are these important? Because again, you want to have a type-safe application. You create a user, you set the user, but you say, okay, the user is going to be read-only. You are not allowed to change the ID or the name or the last name or the email address or the password, nothing. It shouldn't change, but you cannot, in no way you can do this in JavaScript. As simple as you do it in TypeScript. See? You are getting very good at TypeScript, trust me. Let me copy this, put it right here. Next up, we have the record type. So the record type is basically going to create an object with keys of a certain type and a value and values of a certain type. Now, we are not talking about still the index signature. We are going to get to our index signature, but first, let's just convert all of this to record. Now, key of some type and then value of some type. So for key, what we could do is we could say, so we need to have two types, remember? So we have a key which has a type of K and a value which has a type of T. Let's bring this back. Now, for this, we could use this same interface, right? So what I'm going to do is, I am going to, you know what, I'm going to get rid of this. Instead of this, I am going to create, because we have talked a lot about interfaces, I want to introduce you to something else, which is called a type alias. Now, an interface can only be used to type annotate an object, but a type alias can be used to type annotate anything, including objects. So everything. So if you want to type annotate a string or a number or a big int or an array or an object, you could use type aliases. And why would you do that? Let's say we have this let grades, right? Here we have a bunch of grades. So we have grade A, and then a union type of grade B. I'm too slow at this. Let me just copy this. Let me put another pipe in there. I want to have, you know what, just 3 grades is enough, A, B, C. I have this, all right? If I hover on this, it's throwing a lot of errors. It says type number. Where is number coming from? These are like strings. So this is a type. I cannot initialize a type. The way I can initialize a type is using a type alias, and now it works. That's one reason. The other reason is that, let's say I want to have a variable. Let me get, I'm just going to cut that. I want to have a variable. The variable can have only a type of A or B or C. It can't have a type of D. It can't have a value that is D. So what am I going to do here? I'm going to say the type could be A, literally the string A, or it could be, let me put that here, or it could be a literal type of B or a literal type of C. These literals, they are called literal types in TypeScript. So it could be a literally A, literally B, or literally C. It cannot be D, because that doesn't exist within this type. And now, if I were to have A to Z, 26, right? This is going to get too big. So if you want to extract your type to somewhere else, and you call it grades, put your types here, the way you can initialize this is again types. So instead of putting all of that here, we extract it to its own type so we can reuse it somewhere else. And then we type annotate our variable with that. And now you can see it still throws the same error. And it says type D is not assignable type grades. So this is what we use the type alias for. Now, let me get rid of this let. We don't need this. Let me get rid of these as well. So here, I'm going to say let student grades be equal. Now keep in mind, we want to use record. So I'm going to say record. Let's just forget record for now. Let's say I have Alice with grade A, with the grade, which is literally A. Then I have Bob, grade B. And then I have Sandra with the grade C. All right, so this key has one type, the value has another type. Now, the key, for the key, what I'm going to pass in is going to be a type of string. But for the values, what am I going to pass? Should I pass in a string or should I pass in this grades? I could pass both. So if I pass in a string, it still works. We're not using our grades, so I'm going to comment that one out. Now, I told you, I just want to have 3 grades, A, B, or C. I'm going to have Jane come into the picture. Grab a grade of D. Oh, it works. It shouldn't work. I don't want that. So I'm going to bring in my type, and instead of string, I'm going to say grades right here. And now it throws an error. It says type D is not assignable to grades. Why? Because it doesn't exist in there. So this is the record type. The record type gives us a type for the key and a type for the value. If I were to change this to true, it is still going to throw an error. D, let's put A in here. Let's save this. Now, it is basically taking this true as not the true Boolean. It's taking it as the string of true. All right, so that's it for the record type. Let's just in short, whenever we want to have 2 types, for one for key, one for the value, we're going to use the record type. Next up, we are going to talk about the pick. The pick type is going to construct a type by picking properties K from a type of T. Now, if we only want a subset of data, we're going to use pick, right? So how do we use that? Now, for this one, I'm going to get back our interface from required, put it right here. I like interfaces more for type annotations of objects because they specifically denote that we are type annotating an object. With types, you need to read through the type annotation to be able to understand that you're type annotating an object. I'm going to say pick user. And this one should be pick. I don't think we need that one. So here, let's get rid of these question marks. So what I'm going to do, what I did here was we have an interface, there is an ID, there is a name, and then there is an age. Now, I want to say, I want to pick only, let's say, the ID from here, from this user. So I did pass in the user, but then what am I going to pick from here? I just want to have the ID. So when I want to have the ID, is the name going to pass in there? See, it says object literal may only specify known properties. Name does not exist in type pick user ID because we got the user interface and we only got the type of ID from there. Name doesn't exist in ID, only ID exists in there. And as soon as I do that, there is another error because now we are type annotating a string to a number. This has to be a number. So this is pick. You pick 1 or 2 or several properties from an object, and then you only create an object based on that. And the way you could pick 2 things is using this union operator. So now it should have an ID and a name. Let's say Jane. See, so this is the pick. Next up, let's talk about the omit. Let's copy that, put it right here. The pick and omit, they go hand in hand. So it's basically going to construct a type for us by omitting properties K from type T. So I think I have reversed this order. It should be T and then K, because we are omitting K. K refers to the parameters or the properties of an object. So we remove or pick something from the type T, which is our user. And then it should go the same way here as well. It should be the reverse one of that. And omit. Let's comment this one in. We're going to keep the same interface. Let's put that there because it's almost the same thing. So instead of pick user, we're going to say omit user. But this one has to be capital O. Now let's say I want to grab this user, but I want to omit the ID from there. I don't want to get the ID from there. Now if I hover on this, it says it doesn't exist on type ID. And you might be asking, okay, it says ID, it's right here. No, it's the omit utility type. So whatever I pass in here, I'm not allowed to get that. I'm only allowed to get the name, which is Jane. Am I? No. I should get the age as well. Because what did I omit? I omitted what did I delete? I deleted the ID. What is remaining? Whatever is remaining is required. So you need to add the age. 25, and that's how omit works. Let me get rid of this. Next up, we're going to talk about the next utility type, which is exclude. The exclude utility type is used to basically exclude some types from T, which could be assignable to you. Let's take a look at an example of that. Now, you might be having this question like, didn't we just do that using omit? Well, we have the exclude and the extract, which actually work on union types, but then we have the pick and the omit that work on object types. And an interface is actually an object type because we use it to type annotate objects. Let me get this. Let's come down here. Next one is exclude. Now from the type T, we exclude the ones that are assignable to you. So I'm going to create a type and I'm going to say, what should be our type? Let's say primitive. Primitive. So in primitive, we have string or number or Boolean or null or undefined or big int or whatever. So we have these, let's say we have these four types in type primitive. Now, what I want to do is I want to refine this union type, removing one type or more. I want to refine this. So I'm going to create another type. Now in the previous renderers, what we did was we initialized a variable or an object. But in here, we create another type because we want to refine this type. Now, how do we want to refine it? Perhaps we want to exclude any type that is null or undefined. In this scenario, we just want to exclude null. So I'm going to say null primitive. I could just call it that. And in here, I am going to grab my exclude. Now, what type do I pass in as the initial type? This is primitive. Now, what type is going to assignable to you? That is going to be null. So from these types, if I hover on the primitive, we have the type string, we have the number, the Boolean, as well as the null. But if I were to hover on this right here, we have the non-null primitive, we have the string, the number, but we just have the Boolean, we don't have the null. So we excluded that from here. Next up, let's talk about extract. So you can think of exclude as omit, but for union types, and you can think of extract as a pick. I should have perhaps talked about extract first. Extract as the pick for interfaces, but we use extract for union types. So what do I want to do with extract? So I want to extract from the type T any type that is assignable to you. And we use this because perhaps we want to pull out some variants that match our requirements. Let's say from a certain set of types, we just want to get the null ones. So we're just going to say extract. And this is going to give us the null primitive. Now, if I hover on the primitive, we have these 4 types. But if I hover on this one, this is just going to be null. And then we can use this to type annotate a variable. Let's comment these ones out. Next up, we have the non-nullable type. It is going to, this non-nullable type is going to remove all nulls and undefineds from a certain type. Now, in this extract, it just happened to be passed a null here. It just happened that we passed in a null. We could have said, okay, I want to get all the booleans outside. And I would say the bool primitive, let's comment this one in. And if I hover on it, it's going to give me boolean. It's not like specifically null or boolean or string. It could be any type. But then the non-nullable, it actually only works on nulls. It's just going to give us the null values. So this is going to be non-nullable. And then we just have, now since we know what are nullable actually, it's null and undefined, we don't have to actually assign that. And in here, I'm going to pass in undefined as well. This, we could call it primitive, whatever, and then nullable. Doesn't matter what the name is in this scenario. So I am going to pass in our non-nullable here, non-nullable. Now we no longer need this boolean. Save this. So if I hover on the primitive, it has these 5 types. But then what is this utility type? It is non-nullable. So we get everything that has the ability to not be null. And what are those? They are the string, the number, and the boolean. So we only get them. We only get the non-nullable parts. Next up, we have parameters. This is another utility type. Let me comment these ones out. Now, the parameters, this is going to extract parameter types from a function type, and it's going to give us, at the end of the day, it's going to give us a boolean. Sorry, a tuple, not a boolean. At the end of the day, it's going to give us a tuple. Let's put it there. Now, for this one, we're just going to say parameters. And I'm going to create a function. This could be, we have created that function, a function up above. I am going to get this function, copy it, come right down here, put it right here, uncomment it. We have our addition. It has an A, which is a type of number, and then we have a B, which is a type of number. We don't return anything. That's why it has a type of void. Now, in this scenario, we don't care about the implementation of the function. We just want to see our type params, and we don't care about this as well right here. I'm going to create a type for this, and I'm going to say addition params. And this is going to be parameters. And now let's pass in type of addition. And this is going to give us the parameters from this function. So if I hover on this, we can see we have a tuple in which we have A and B. A is type number, B is type number. Very, very cool. Next up, we have constructor parameters. This is going to extract parameter types from a class constructor as a tuple. So let's take a look at that. Let me bring this down. This is going to be constructor parameters. Let's say we have a pet class, right? Inside here, we're going to have our constructor. It's going to be public. We have a name for our pet, and then public, we have an age, which is of type number for our pet. If I say type pet params, let's grab our constructor params from here. Now, as soon as I pass in the type of pet, this is going to give me all the parameters that were used within the class. And from OOP, you know that if you might know that if you use constructor, the constructor is basically, the job of it is to grab all the arguments that are passed for this class when we instantiate that. All right, so if I hover on this, we can see we have our name, which is of type string, and we have age, which is of type number. This is our constructor parameters. Next up, we have the instance type. So this video is basically, we jump into almost all of the types that we have. So let's talk about our instance type. So an instance type is going to extract the instance type of a class or constructor function. We use it if we need the shape of a constructed class instance. So here we have, you know what, I could use the same thing here. Let me copy this, put it down here, comment this part out. We can have two classes with the same name. This is going to be instance type. All right, now we are going to grab the types from this class. The class instance basically refers to whenever we instantiate a class, and this is going to be instance params. And now instead of the constructor parameters, we're going to say instance type. Save this, let's hover on it. What is the instance of this? This is the instance of this is pet. The reason for this is because, now keep in mind, we're not getting the parameters from the constructor of this class. We want to get the instance of this class. And whenever we instantiate the class, it's going to give us this pet. So we essentially got that. So this is the instance type. The next one that I would like to talk about is the return type. This is going to be a return type. And we use the return type to extract the return type of a function type. This is handy for using a function's output type without manually duplicating it. So let's come right here. We still have our function. It was, where did I put that function? Right here. So I'm going to get our function, come right here, put it right here. Now I need that implementation. Let me comment this one in. I'm going to say return a plus b. Now, since it returns something, it cannot be void. So let's get rid of the void. Now, what is it? I mean, what does this function return? You could take a look at the function signature and just guess it, or you could hover on it. It's going to return a number because we are combining two numbers. So I'm going to say number. Now, let's say I want to get the return type of this function. So I'm going to say type add return or addition return. And then this is going to be a return type of addition. Addition. Save that. Let's hover on it. And there we go. It is number. Sometimes the function may not be type annotated and it would still give us number. Very cool, right? Next up, we have, let me see. So we talked about a lot of utility types. I think that is enough for our utility types. Next up, what I want to talk about is something that I briefly touched upon. That was the literal types. Let's talk about some literal types. So as the name suggests, the literal type can only be that thing. It can't be anything else. Let's say we have a direction type alias. in direction, we say, okay, you can go either right or left or up, up or down. Let's say this is my directions. That's it. These are the directions. You can't add anything else inside of it. Now, this is a union of literal types. Why is it called literal types? So what is the difference between that and between, let's say, some user, or let's just say user? We have a string, and then we have a number. Let's say switch, string, or number. So what is the difference between these two? Why am I calling this one a literal type, and why am I calling this one just a simple type, a union of two types? The reason for that is when we say string, it's not literally the word string. It's any string possible to your imagination. Any string. When I say number, I'm not literally saying this number, or I'm not literally saying 1, 2, 3. I'm saying from negative infinity to positive infinity, any number. That could be here. So it's not literally something. But when I say direction, I'm saying literally this thing. It can't be anything else. Literally R-I-G-H-T. And then literally this. So it's not, it does look like a string, but this is actually a literal type of right. And this is how you create custom types. So this is, TypeScript or JavaScript gives you string, but then you create something that's called the right type, the left type, the up type, the down type. It just happens to look like a string, but it is not a string. It's a type. So if I were to say, let a robot move, and if I type annotate this with direction, come on, direction, and if I come right here, I need to pass in something. I need to say 1, 2, 3. Does that work? No. Why? Again, right-hand side versus the left-hand side. The right-hand side is, you can see, it didn't take 1, 2, 3 as a type of number. Why? Because the variable has a type of literal. So whatever you pass goes as a literal as well. So it's a literal type of 1, 2, 3 is not assignable to type direction. If I say up, it still doesn't work because it should look like that type. When I say up, it should be up. Even this doesn't work because in here, it is lowercase u and p, but in here, u is uppercase. So again, it should be literally that thing. But if I say, let switch, let's just name the variable switch as well. This should not be used. So let's say switch match. I don't know. Match. This could be 1, 2, 3. And now this is not literal. This is the actual number type. Or this could be a string of 1, 2, 3. And it would still work. But it doesn't work here. So this is the difference between a literal type and some general type like string or number. Now when it comes to literal types, we have literal string types, which look like strings. But then we could have direction num. We could have literal number types as well. Let's save that. And now if you use this, it should be 1, 2, 3, 4. It does look like a number, this 1, 2, 3, 4. These are not numbers. These are types. So this is the literal type for numbers. We could have some on off, some literal Boolean types as well. False. And now again, these are not strings, these are not Booleans, these are the literal TRUE and FLSE. That's it. So this is everything you needed to know about literal types. Let me just say literal types. Now that you know that, let's move forward. Let's talk about some union and intersection types. So we already talked about union. Union is one or the other. When you talk about a union, it is never both. So a union is one or the other, right? Union. And we have seen a lot of unions. We have not seen something called intersection. An intersection type is denoted using the ampersand, and it has to be both. If there is 2, it has to be both. If there is 3, it has to be all 3. It can't be anything else. So I'm going to create 2 interfaces. Let's say user. This is going to contain a name, which is string. And then let's create another interface as well. And I am going to change the name, and I'm going to say employee. This is going to have an employee ID. And this is going to be of type number. Now, there is one thing inside the user, there is one member inside the user that I need inside the employee as well. Basically, I want to combine these 2 interfaces. There are 2 ways to do this. We're going to use our types. Interfaces can be extended. We are going to talk about those very shortly, but for now, let's just use our type. I'm going to say employee person is equal to, I could say user or employee. Let's save that. Now, if I hover on this, you can see it gives me user or employee. Now, let's type annotate an object with this. Let's say let user person. Let's type annotate this with we are going to type annotate it with this one. So let's get that. And now if I hover on it, it says, this is not assignable to type employee person. Now, as soon as I do the name, which was of type string, let's say Jane, it's okay. Where is the employee ID? It doesn't ask me. Why? Because it's a union. It says one or the other. But intersection is strict. If I change this to an intersection, there is immediately a squiggly line yelling at me that, okay, you did the string, but it is not assignable to employee person. And I'm asking, okay, why is that? It says because employee ID is missing in type this, the type that you created, but it is required in this type. Employee ID is declared here. See? On line 148. So how much more cooler do you want it to be? And in here, I'm going to say, and the good thing is, as soon as I do employee ID, I get auto completion as well. Let's say 1, 2, 3, whatever. Now, if I hover on it, everything is okay. So this is the difference between intersection has to include all of them. Union, as long as one is there, it's okay. It's going to pass. So this is the difference between intersection types and union types. And again, all of these are types in TypeScript. All of them are types. Next up, I want to talk a little bit about types and interfaces, and then we're going to talk about enums. All right. So when it comes to, we are using types left and right, but type aliases. But we need to really understand what is happening here. So when it comes to types, you can use types to create anything. Let's say you have let my age be equal to a type of age, and this could be 1, 2, 3. Now here I could use type my type age. This is equal to a number. So you could use a type alias to extract the type of a variable. You have seen how we did that for an object. We extracted this type. The reason that we do this is because whenever we have like some gigantic type, it is better to extract the type so it's more readable. We just put the type here. And if I click on it, just hold Control and click on it, it's going to navigate you to that type. So you could use it to type annotate a number, you could use it to type annotate a string, a boolean, whatever. That's a type alias. But an interface can only be used to type annotate an object. So the example of that is right here. So if I were to grab this interface user, put it right here, uncommented, this is an interface, right? So I'm going to say, let my name be equal to Jane. And then I'm going to say this is going to be user. There is going to be an error. Why? Because it's type string is not assignable type user. What is type user? If you hover on it, you can see it says user. There's this object syntax with one property inside of it. So this is the difference between types. Type aliases can be used to type annotate objects as well as everything else, but interfaces can only be used to type annotate objects. So this is one last thing. And yeah, I should mention that interfaces can be extended using classes. So that's something that types cannot do. So let's say I have this interface and I want another interface to grab the name from here as well. So I'm going to say interface employee extends which interface? User. And now I could say employee ID is equal to a type of number. If I hover on this, you can see the type is employee. And now let's go ahead and let's type annotate an object. Let's say let Bob have a type of employee. Now there is an error. If I hover on this, it says this is missing the properties from employee. What are the properties? One is employee ID and the other one is name. So we need to add the name, which is Bob, and the employee ID, which is 1. So you can extend an interface as well. All right. And now in this scenario, this interface has the name inside of it as well as the employee ID. Before wrapping the topic of interfaces, there is one last thing that I want to talk about here, and that is an index signature. An index signature allows us to basically define our types for dynamic object keys. If I were to take a look at our interface user, let me copy that, comment that one out, comment these ones out as well. Let's just put it right here. Now, what does this interface say? This interface says that I am going to type annotate an object with one property. The property is and will be name, but the value that it accepts could be any string. Now, what if you want to say, okay, the property that I want to have, it could be anything, as long as its type is a string. Well, that's where you would use an index signature. And for that, you're going to open up square brackets. You're going to say key, but then the key is going to have a type of string. Now, the key type is string, and the value that it accepts is also a string. Let's type annotate this. I am going to say const user. Now, I could say name Jane. That could work. But then I could also say email jane@gmail.com. That could also work. I could also say role senior dev. I could also say that. Let's provide a comma there. So this is the structure for an index signature within an interface. It doesn't matter how many times you repeat it, as long as the key is of type string, it is going to work. All right, so with this, our topic of type aliases and index signatures comes to an end. Next up, what I would like to talk about very shortly is something that doesn't actually exist in JavaScript, which is enums. And enums basically allow us to name a set of related constants. Let's say you want to keep track of state 1 and then 0. So if you want to show the variable, you're going to say 1, otherwise you're going to say 0. Or you want to show model, true and false. Now, what is this true? You need to type annotate that. You need to create a variable, initialize it, so you know what that is. Well, enums in TypeScript allow us to do something like that. It just, if you have a constant and you want to basically check its state, you could use enums. That's what they're created for. Let's say we have our direction. And in here, I'm going to say up, down, and then right, left. This is our direction. Now, how does it work? So whenever you create an enum, it doesn't matter how many things you provide inside of it, it's going to start counting. So this is going to be number 0, number 1, 2, and 3. So whenever you want to basically grab number 0, you're just going to say direction.up or whatever name you want to provide it. That's going to be number 0. Or you want to create an enum that is basically going to have a status. Let's say the status could either be success or the status could be failed. Now, for these, the enum will also provide a numeric value, but you could initialize it to a textual value or a string value. And now if I hover on it, it's going to be success. So what is the status? Success or failed? What is success or failed? That is the status. So instead of creating a different variable, I create a disposable type that will not exist when it goes to JavaScript. If I just were to add a const in front of it as well. Now let's save this. I just saved it. Let's go to terminal. In here, I'm going to say TSC. Let's compile this because TypeScript cannot be read by the browser. We need to compile it to JavaScript. There we go. Here is it's the exact file name, but the extension is going to be different. Double click on it. Close the sidebar, close terminal. Let's come down. There we go. So this is our direction in enum. But where is the other enum? Where is this enum? Because we said const, it was completely removed from JavaScript. It wasn't compiled. That's it. So this is a typical enum. This is a const enum. With const enums, you just get a variable declaration. If I were to use this, let's say let message status, and then I'm going to grab the status dot, let's say failed. If I save it, we just get, we need to compile this again. If I come right down, you can see we just got a variable declaration. But with normal enums, you don't get variable declaration, you actually get an object. So we initialize an object and then we populate it with these data. That's why we use enums. There we go. Let's save that, comment and save. I'm going to put that here. Now, next up, what I want to talk about is several different types in TypeScript that are really important to understand, and I'm going to go over them very quickly because they are really, really easy. The first type is going to be the function type. We have already talked about it. I just want to put it in context. So if we have a function that says addition, it accepts a number, the type is going to be number. B, the type is going to be number. The function is going to return number. And then we could say return A plus B. So this is our normal function. But if you remember, I told you that we could use type aliases to type annotate a function as well. So this is our function. This is the return type. But what is the actual function type? For that, we're going to say type add func. And then, now the way you would type annotate, you would actually extract the type of a function would be to the way you would create a function, the syntax of that. So aside from this, what is the syntactical feature? We have a pair of parentheses. There we go. And then we have basically some way to show what the function returns. So what does the function return? It returns number. Does it have any arguments? Yes, it does. Let's just put it right there. And that's it. This is the function signature right here in type format. And now we could use this to type annotate any function that we want. Let's use an arrow function. Do addition. I'm going to type annotate it to add func. And now as soon as I do that, there is a certain structure that I need to abide by. I could say A, B, and then what is this going to return? A plus B. I'm going to do an implicit return, so it's going to say A plus B right here. Now if I hover on this, you can see add, this is the return type, but what is the type of A? It's a number. Type of B, it's a number. Correct? Cool. Very good. This is the function type, the official function type. Next up, let's talk about the mapped type. Let's say I have an interface called person. So within this interface, I have a name with a type of string. I have an age with a type of number. Let's say I want to map through this. See, mapped type. It's an equivalent of the map method that we have for arrays in JavaScript or TypeScript. We map through the array, and for every array item, we do something. But in this scenario, we map through the type, and for every type, we do something. So for every type, I want to grab the type and I want to make it read-only. But how am I going to map through it? K is going to be our mapping variable. Now, we go inside the type, so we need to have type of. Where is the type of coming from? For this object. And then what do we want to have at the end of the day? We want to have a person type interface with K types inside of it, where all K types are now read-only. So we need to put this inside our type alias. So I'm going to say read-only person. Let's open up parentheses, put that in there. Let's save this. It says person. The reason for that is because of this type of. This is not type of. Now, we are not getting the type within the square brackets. We're getting the key. So we need to do key of person. And then for every key, we put that inside the person. So now all of this is going to, whenever we initialize this type, this is going to be read-only. Now, what about if you want to make it optional? You could map through that and make it optional as well. And you could apply all of the utility types that we have talked about. So in this scenario, I'm going to say optional. Save that. So instead of this, I'm going to get rid of it. And I'm just going to come right here and I'm going to put in a question mark. That's it. So all of this is going to be optional. These are called mapped types, where you map through types. And for every time you get a map or you get a type, you do something with that. After that, we have the conditional types. Conditional types let us express logic in types. For example, they look like a T that would extend U if something is true. Otherwise, it's going to extend something if something else is true. So how does that work? Let's actually go ahead and create a type. I'm going to say as string if this T is a string. That's what we're looking for. So we're going to say T extends string. If this is true, what do I want to do? I want to say yes. Yes. Otherwise, I'm going to say no. Let's save that. So I'm going to say type A. This is going to be equal to as a string. Let's pass in a string. This is going to give us a yes. So let me hover on it. There we go. We got a yes. And then if I were to pass in a number, what is that going to give me? That's going to give me a no. There we go. So this is conditional types. Very similar to the concept of arrays in JavaScript and in TypeScript. Let's move forward. The next type is the indexed access type. This is going to give us the type of a property by its key or index. All right. So let me come right here. Let's get our interface, quite a famous one. Within here, let's say I want to grab the type of the thing that is called name. How am I going to do that? So I'm going to say person name. This is very, very cool. So you grab the person and you pass in which one do you want? You want the name. What is name? What type does it have? It has a type of string. And now I could use dynamically, I could use this type to type annotate anything I want. Any other name of the user that I want. Finally, we are going to talk about template literal types. These will allow us to basically construct string literal types. So if you're familiar with the template literal, where you have backticks and you can use the value of a variable, we do the same thing, but we use the value or the type for a specific variable that we have created. So let's say I have event name. I'm going to set it equal to, I'm going to grab my backticks. This is right to the left of the one key on the keyboard, backticks. And I'm going to say, okay, since it's an event, I'm going to say on, and then let's grab our $sign for template literals right here. And then I'm going to pass in the string. Let's create a variable and type annotate it. I'm going to say my event is equal to event name. All right. Now, my event could be on click. It could be on click. It could be on hover. But can it be change? No, it can't, because we are missing the on in there. It has to be on. Has to be on something. So this is how you would create template literal strings, but for types. All right, and these you can use to actually build up valid string patterns at the type level, ensuring correct usage. With this, our video comes to an end. This was really fun. We did talk about a lot of things, and that is going to be it for TypeScript. Next up, in the next video, we will talk about Python data types, and after that, we're going to jump and talk about Go data types and Rust data types. And then we will have our very first challenge of this tutorial series. See you in the next one.